Hello everyone. I'm going to present the software presentation for the data science capstone project. So in my project, I'm planning to develop an advanced deep learning models to classify over 14 lung diseases from chest X-ray images using radiomic features. So in this project, I'm going to use callbacks from TensorFlow Keras. The idea is to use the VGG16 architecture as a backbone network and fine tune it to extract radiomic features that capture patterns of texture, density, and structure in lungs. However, rather than training the model in a standard static way, I plan to integrate Keras callbacks to create a smarter and more adaptive training environment. So these callbacks will allow the model to monitor itself and make adjustments in real time and ensure the learning process is efficient and optimize it for medical image data. So, going back to the what exactly the Keras callbacks and what we are going to deal with them. So in this Keras callbacks are built-in tools in TensorFlow that enables dynamic interaction with the training process, allowing for the real-time like it's instead of passively training the model for a fixed number of epochs, callbacks acts as a training assistance. The monitor performance and take intelligent actions such as stopping training early when overfitting begins, or lowering the learning rate when progress stalls, or saving the best performance model automatically out of all the models we are running. So in this planned project, these callbacks will play a key role in managing the training of our VGG16 base model, especially since this radiomic data extracted from X-rays can be sensitive or overfitting. Using callbacks will help maintain model stability and improvise the generalization, which is essential for building a very efficient, clinically useful classification system. So So these callbacks in my upcoming implementations, I plan to use three main callbacks: early stopping, reduce LR on plateau, and model checkpoint. The early stopping callback will stop training automatically when the validation loss stops improving, ensuring the model doesn't overfit the training data. Whereas the reduce LR on the plateau callback will gradually lower the learning rate when the model improvement slows down, which helps it learn subtle radiomic features more efficiently. So finally, the model checkpoint callback will save the model weights every time it achieves a better validation performance, allowing us to make always retain the best version of what we have tested. So together, these callbacks will make model training process adaptive, self-correcting, and less independent on manual tuning. So all of which are critical when dealing with high dimensional radiomic data. Uh, so while we are planning, uh, so while so the workflow plan I built combines radiomics and deep learning using the VGG16 network as the base model. I will fine tune it on chest X-ray images to extract radiomic features that represent texture variations, pixel intensity distributions, and lung structure patterns. Before training, I have to apply image data generated to augment the data generating rotated, flipped, and scaled versions of X-rays to increase diversity and reduce the bias. So while training, the Keras callbacks will automatically monitor the variation loss. Early stopping will pause the process when the model reaches optimal performance. And finally, the reduce LR function. The planned integration is expected to produce more reliable radiomic representation and more stable disease classification performance. So once implemented, this callback driven training approach is expected to significantly enhance model performance and efficiency. So I really appreciate the shorter training times, improving stability and validation data, and higher precision recall metrics for disease detection. By preventing this overfitting and automating optimization callbacks, this will help the model focus on meaningful radiomic patterns rather than noise. This will especially be valuable for classifying all 14 lung diseases where subtle differences in texture or opacity can be single distinct conditions. In future, I plan to extend the work by incorporating some custom callbacks such as early stopping based on F1 score or automatic adjustment of augmentation intensity to further refine the training process and improve clinical performance. Thank you.